Hi everyone. Let's start with review of the real number system before we go into chapter 4. Define each of the following sets of numbers and fill in the graphic organizer below. So natural numbers are positive and non-decimal number. And non-decimal number Also, natural numbers are the type of numbers that you use to count items or things. So we cannot count 0, so we must exclude it when we're talking about natural numbers. So for example, we can say natural numbers have to start with 1, 2, 3, and so on. Whereas whole numbers, we're used to saying it like, oh, round up to whole number, or, like counting numbers. But whole numbers actually include 0 as well. So basically, whole numbers are all natural numbers with 0. So we can say that 0, 1, 2, and so on are the examples of whole numbers. Integers are positive and negative whole numbers. Positive plus negative whole numbers. For example, we can say negative 10 is an integer, negative 2 is an integer, 0, 1, 3, and so on. Rational numbers are any number that can be represented by a fraction. So number that can be represented by a fraction. For example, we can say 0.2, because we know 0.2 is 2 over 10, or we can say it's 1 over 5. You can represent that decimal into fraction, therefore it's a rational number. We can also say 5 is a rational number because we can rewrite this as 5 over 1, and also a negative whole number, or basically integers, are all rational numbers. Irrational numbers are the numbers that don't have repeating decimals or that cannot be written in a fraction form. For example, square root of non-perfect square. We know square root of 3, when you punch it into your calculator, you will get some decimal place that's not repeating, and therefore that's a rational number. Also, there's a very common example we use. We have pi. Pi has decimal places that does not repeat. It just goes on, and we cannot figure out the pattern. Also, another example would be a constant e. We might not be familiar with it yet, but we'll go over it later on. Finally, real numbers. Real numbers are including basically all numbers. All numbers that you can see on the number line are real numbers. Rational and irrational numbers. Now that we have those examples, we can actually try filling this organizer. So we'll start with the smallest box here. So you can kind of see that natural numbers are the smallest set of values that we can get. So if, for example, natural numbers are 1, 2, and 3, so we can say natural numbers here. Whole numbers include everything in natural number plus 0. So whole number is the box right that's wrapping the natural number. And the one that includes the entire whole number system is called integer, because integers include positive and negative whole numbers. And on top of that, rational numbers include everything in the integers plus fraction forms that we can, like with the decimal places. That's non-repeating. And finally, on the right side here, there's a separate box here. This one would be irrational number. And then the system, the number system that includes both rational and irrational would be the real number. Moving on to the next page, let's work on practice 1. Label each of the following numbers as rational, irrational, or neither. For part A, 1/4 is a fraction. If a number can be written in a fraction form, it is a rational number. Part B, it's a special type of roots, and if you punch this into your calculator, you actually get negative 0.5. So it's safe to say that this is a rational number. Part C, cube root of 8. It can be rewritten as cube root of 2 times 2 times 2. This just simplifies to 2. So 2 is a nice whole number, or you can call it a natural number, which would be included in a rational number. Part D, square root of 64. This is a perfect square. So we can say 8 is square root of 64. And 8 is a nice whole number, therefore included in the rational number. Part E, 0 is not a natural number, but it is included in a whole number, therefore included in integer, and therefore included in the rational number. Part F, 0 divided by any number is equal to 0, therefore it's also rational. Part G, negative square root of 2. If it's a square root of non-perfect square, then it automatically becomes a rational number. Part H, square root of 0.13. If you punch it into your calculator, you can see that the decimal places you find will not be repeating, but not only that, 0.13 is not a perfect square. So we know right away it's a rational number. Part I, 3 divided by 0 is a special case because any number divided by 0 is undefined. So we can say it's neither rational or irrational. Lastly, part J. 6 times pi, because pi is irrational, 6 times pi has to be irrational. Moving on to practice number 2. Place each number below into the real number system diagram. Before we start by analyzing the numbers, let's actually first label the boxes first. So we know that the smallest box here is called natural number box, and the number that includes all natural numbers are whole numbers, and all the numbers that include whole numbers are integers. And then the bigger box will be rational number. On the right hand side, this is irrational numbers. Alright, so we'll start with -4. So we know that -4 here is a negative whole number, so which is an integer, -4 here. Actually, let's use red. -4 is an integer. So that's done. -3/4 is a negative fraction. Integers don't include a fraction, so then it has to be rational. -3/4 is a rational number. All right, next one is 0, because we know that natural numbers don't include 0, whole numbers include 0. So if we have 0 in a whole number, which we can confirm that integers include 0 and rational number includes 0, so the smallest number system we can put the 0 in is a whole number. So that's done. √3. And we've discussed this before. Because 3 is not a perfect square, if we square √3, we're not going to get a nice decimal, like a repeating decimal places. So √3 is a rational number. Next one, 1/4, it's a fraction. We can say that's a fraction, therefore it's a rational number. 5 is a nice whole number, except the smallest numbers, like the system set of numbers we can put that into is a natural number. (7.3), we do have a decimal place here, but it terminated. It didn't repeat. It's safe to say this number, 7.3, can be written in a fraction form. We can say it's 73/10. Therefore, 7.3 is a rational number. Finally, 1.2593 and etc. That 3 dot here just means it's continuing decimal places. So when it comes to a number with decimal places that's non-repeating and non-terminating, we know right away that it's an irrational number. So we can say it's 1.2593 and ...